Have you ever wondered how suspension bridges, these magnificent structures, manage to stand firm, carrying tons of weight across vast expanses of water or land? These are not just feats of engineering, but also testaments to human ingenuity and determination. Suspension bridges, with their towering pillars and gracefully draped cables, are more than just structures. They are symbols of connection, linking cities and even countries, enabling the flow of people, goods, and ideas. The science behind these bridges is as fascinating as their aesthetics. It's an intriguing mix of physics, materials, science, and architectural design that allows these structures to withstand not just the load of traffic, but also the forces of nature. From the earliest rope bridges of the Incan Empire to the modern steel giants that span some of the world's busiest waterways, suspension bridges have been pivotal in shaping our world. Join us on this journey as we traverse the fascinating history, design, and engineering of these architectural marvels. The story of suspension bridges begins thousands of years ago. Long before the steel behemoths we marvel at today, the humble beginnings of suspension bridges were rooted in the basic human need to cross obstacles. The earliest ancestors of these engineering marvels were simple rope bridges, constructed using natural materials like vines and bamboo. These bridges, though primitive, were a testament to human ingenuity and the desire to overcome physical barriers. In the rugged terrains of the Andes and the Himalayas, local people weaved together strong vines or sturdy bamboo to create bridges that spanned treacherous gorges. These bridges, while lacking in modern technology, were remarkable in their ability to withstand the forces of nature, and they were vital to the communities that depended on them for travel and trade. As engineering knowledge progressed, so too did the complexity and strength of suspension bridges. The advent of iron chains in the 18th century marked a significant turning point. Iron chains, stronger and more durable than vines or bamboo, allowed for longer and more stable bridges. The Menai Suspension Bridge in Wales, completed in the early 19th century, was one of the first large-scale suspension bridges built using iron chains. It was a marvel of its time, showcasing the potential of this new bridge design. The evolution of suspension bridges didn't stop there. The invention of steel wire in the late 19th century led to an even greater leap forward. Steel, being stronger and more flexible than iron, revolutionized bridge design. The iconic Brooklyn Bridge in New York, completed in 1883, was one of the first to use steel wire, setting the standard for future suspension bridges. From vines to iron chains, the journey of suspension bridges has been a testament to human ingenuity. Over the centuries, these bridges have evolved from simple rope structures to intricate feats of engineering, embodying the spirit of innovation and the relentless pursuit of progress. The design of suspension bridges, while seemingly straightforward, is a complex feat of engineering. Let's dive into the details. The basic design of a suspension bridge is comprised of three main components: the anchorages, the towers, and the cables. Anchorages are the foundation, the unseen heroes of the bridge. Buried deep within the earth or embedded in concrete, these structures are designed to hold the weight of the entire bridge, including the towers, cables, and even the traffic that crosses it. Rising majestically above the water, the towers are the most noticeable part of a suspension bridge. They bear the weight of the deck and distribute these loads to the anchorages through the main cables. Their design is not just about strength, but also stability and resilience, especially when it comes to withstanding the forces of nature, such as high winds and earthquakes. Connecting the anchorages and towers are the cables. These are not just simple strands of metal, but are made up of thousands of individual steel wires, bundled together for maximum strength. They are draped over the towers in a parabolic curve, a shape derived from the principles of physics, which efficiently distributes the load of the bridge. But it's not all about the physical elements. Underlying the design of suspension bridges are the principles of tension and compression. Tension, the pulling force, is experienced by the cables, while compression, the pushing force, is handled by the towers. These two forces work together, balancing each other out to maintain the stability of the bridge. This intricate balance of forces and the careful selection and placement of materials is what makes these bridges stand the test of time. Beyond their functionality, the design of suspension bridges also plays into their aesthetics. The graceful curves, the soaring towers, and the intricate cable patterns create a harmonious blend of science and art. The mastery of design is what makes suspension bridges not just functional, but also aesthetically pleasing. Modern suspension bridges are symbols of engineering triumphs, standing tall against the tests of time and nature. These structural masterpieces are testament to human ingenuity, each with its own unique features and historical significance. Take the Golden Gate Bridge, for example. Opened in the late 1930s, this iconic structure is known for its international orange color and Art Deco design. The bridge, spanning over a mile in length, was a marvel of engineering for its time, using over 80,000 miles of wire in its two main cables. Despite the harsh maritime climate, the Golden Gate Bridge still stands strong, serving as a symbol of the vibrant city of San Francisco. Then there's the Brooklyn Bridge, an embodiment of the spirit of New York. Completed in the 1880s, this historic bridge was one of the largest suspension bridges of its era. Its construction was a feat of engineering and human determination, overcoming numerous challenges, including the caisson disease. To this day, the Brooklyn Bridge is a beloved fixture of the New York skyline, its Gothic towers a reminder of the city's rich history. And let's not forget the Akashi Kaikyo Bridge in Japan, the longest suspension bridge in the world. With a central span stretching nearly 2 kilometers, it is a marvel of modern engineering. The bridge, completed in the late 1990s, was designed to withstand the region's powerful typhoons and earthquakes. Its state-of-the-art technology and innovative design have set new standards in bridge engineering. Each of these bridges, from the Golden Gate to the Akashi Kaikyo, has its own unique story to tell. They're more than just structures of steel and concrete. They're symbols of progress, of human ambition and perseverance. These bridges stand as a testament to human potential, connecting cities and cultures. Suspension bridges have revolutionized transportation and urban development. Their impact is undeniable, becoming lifelines that connect communities, cities, and even countries. Imagine a world without these magnificent structures. It would make trade and travel a daunting task, wouldn't it? Suspension bridges have made possible the seamless movement of goods, services, and people. These bridges are like arteries pumping life into economies and societies, but their influence goes beyond transportation. They have shaped our cities and urban landscapes. By linking areas separated by vast bodies of water or deep valleys, they've spurred urban development in places that were once inaccessible. They've enabled the growth of cities, the expansion of commerce, and the blossoming of cultures. In essence, these bridges have not just bridged physical gaps, but also social, economic, and cultural divides. Suspension bridges, with their history, design, and engineering, have truly shaped the world as we know it today.